Yes. So in the previous class, what all things we have discussed? So we have completed the types of ligands, right? So we have seen what is a monodentate or unidentate ligand. Then we have discussed what is poly or multidentate ligand. Then we have discussed something called as chelating ligands. Okay. And then amphidentate ligands. Right. Then we have seen all the examples also. So different types of ligands. Right. Then we have discussed upon coordination number. Okay. Coordination number and the geometry related to the coordination number. Right. Then we have discussed something called as coordination entity, coordination sphere. Okay, then how to find the charge, okay, charge of the complex ion. So that also we have discussed. Then coordination polyhedron, okay, the spatial arrangement of ligands, right, attached to the central metal atom. So this also we have discussed. So now, uh, then we have also discussed about what is a homoleptic and heteroleptic, right? So what is homoleptic? Yes, when you have only one type of ligands attached to the central metal ion, then they are called as what? Homoleptic ligands. Then what do you mean by heteroleptic ligand, students? Yes, what do you mean by heteroleptic then? Homoleptic means when you have only same kind of ligands attached to the central metal atom. Okay. So what is homoleptic then? What is a homoleptic? Sorry, what is heteroleptic? Homoleptic means complexes in which the central metal is attached to only one type of ligand or one kind of donor groups are present. Okay. What do you mean by heteroleptic then? Yes, what do you mean by heteroleptic? Heteroleptic means what? Complexes in which the metal is bonded to two or more than one kind of tonality. Yes, very good, Yamuna. Yes, very okay. So complexes in which the metal ion is bound to more than one kind of donor groups, they are called as heteroleptic. Okay, very good. Fine. So this also we have discussed. Then we had started with what? We had started with nomenclature. Very important, right? Nomenclature. So let us see nomenclature. Then we'll continue with the same. Okay. So so first one, nomenclature. That is the order of naming the ion. Right. First one is what? Order of naming the ion. So first will be what? First, always in positively charged and negatively charged coordination entities, you are going to write first name of the cat ion. Okay, and then your anion. So this was the first one when you are writing the name of the ion, order of naming the ion. Second is when you are naming the complex ion. When you are naming the complex ion, okay, the ligands are named, okay, first. So first the ligands are named, okay, and then your central metal atom, okay, or central metal ion. First, your ligands is named and then your central metal ion. And the central metal ion, its charge is written in Roman number, okay, just beside the complex, okay, in the your so, after naming the ligand, after naming the complex ion, central metal ion, then you have to write it charge just beside the central metal ion in brackets in with its Roman number. Okay, that or your oxidation number should be represented in Roman number. Fine. Then, so first name the central metal ion, then, sorry, name the ligand, then name the central metal ion, and then coordinate oxidation number of the central metal ion. Suppose, suppose, suppose Fe CN6 3 minus. Okay. So how many six are there? So hexa, cyanido, okay, ferret, and then what will be the charge? The charge is 3. X plus 6 into minus 1 is equals to minus 3. X plus 6, sorry, minus 6 is equals to 3. X minus 3 plus 6, x is equals to plus 3. So this 3 is represented in bracket. Okay, fine. Next is naming of ligands. How to name the ligands? So you have to name the, if you have more than one type of ligand, then you have to follow alphabetical order, right? Then we have seen the names also, right? How to name the anionic ligands, how to name the, okay, anionic ligands we have seen, and how to name the neutral ligands. So in the last class, I have given you the, this, right, names. So let us see now next. Okay, so let us see the next one. So, okay, this is the naming itself. So now suppose, so you have to use, what you have to use? You have to use the numerical prefixes. Okay, you have to use the numerical prefixes to indicate the number of individual ligands. Suppose you have one ligand. Okay, you have one ligand, then you have to write it as mono. If you have two, di. If you have three, tri. If you have four, tetra, and so on. Okay, so this is the way you are going to use it when you have more than like more number of ligands. Okay, then so the number of the individual ligand in the complex ion is determined with this prefixes. Okay, then when the name of the ligand itself includes the prefix like di, tri, tetra, then to avoid the confusion, okay, suppose some entities they already first only they have di, tri, so that time to avoid the confusion we are going to use that time base tris, okay, tetrasis, tetratis, okay, etc. For the naming the compound. Suppose I'll give you example cobalt En3Cl3. Suppose this is a example. So how we are going to name this? First of all, so this is what En is what? En is your ethylene diamine. So in the name itself, what is there? Di is there, right? So again, how many numbers of ethylenes are there? Three are there. So you cannot write triethylene diamine because again it will be confused, right? Because you have diamine in the parent ligand itself. So how you are going to name it? Now you are going to use this. Okay. So there is tris because it is three. So we have to write tris. Then how you are going to name the ligand? Ethylene, ethylene diamine, ethylene diamine, then cobalt, right? Ethylene diamine, cobalt. What is the oxidation state? It is 3. And then outside the, what you have chloride. So it is, the name is this. Okay, tris, ethylene diamine, cobalt 3, chloride. Okay, so this is the name. Suppose one more example, Ni Cl2 PPH3 twice. So again, we have two ligands here. Okay, one is chloro, another is triphenyl phosphine. Okay, PPH3 is triphenyl phosphine. So let us write. So first will come your triphenyl phosphine or your this, what is that? Triphenyl phosphine, tri or chloro. Chloro will come first, right? When you are using the alphabetical order, which will come first? Your chloro will come first. So how many chloros are there? Two chloro. So we'll write it as dichloro. Okay, dichloro. Then, sorry, dichlorido. Okay, dichlorido. Then this is what? Triphosphine. So we have two. So we'll write it as bis. Okay, bis. Then triphenyl phosphine. Okay, triphenyl phosphine. So this is your ligand. Then which is your this? It is nickel. Okay, and the oxidation state of nickel is 2. Oxidation nickel is 2 because X minus 2. Okay, then plus 0 equals to 0. So X is equals to plus 2. So this is the way you're going to find the oxidation state. Now for cobalt, it is X plus 0 equals to plus 3. Okay. Oh, sorry, minus 3. So X is equals to plus 3 because each chlorine has minus 1. So it will be minus 3. So this is plus 3. So like this. Understood? So like this, you have to find the charge and you have to write the complete complex. So, okay. So like this, you're going to use. Is it clear? Is this point clear? Okay, so let us go for the next one. So now we have seen how to name the ligands. Now we will see how to name the central metal ion. Okay, so naming of central metal ion. Naming of central metal ion. Okay. So if the complex ion is neutral or cationic, okay, so the metal ion is named without any characteristic end. So if it is a neutral molecule, if you have a neutral or you have a cationic, then the name is given, okay, uh, no any characteristic name is given, so its proper name is given. But if the complex is anionic, so if you have a negative and this, then the central metal ends with ate. Okay, if the um, if the complex is negative, okay, then it will end with 8. So if you have neutral or cationic, then you are going to write the name of the metal ion itself without any change in the names of the metal. But if you have a anionic complex, then whatever the name of the complex will be, that will end with ate. The central metal ion, its name will be ending with ate. So let us see example, then you will come to know. Okay, so I'll give you, please note down these examples. Okay, so NH3 4 plus 2. Suppose, so this is a complex. Okay, so this is a complex. So can you try? Can you try, students? Can you try? Anybody? Yes, anybody wants to try? How many? First, you have to name the ligand. Okay, one type of ligand is there. That is a amine group is there. Amine ligand. So how many are there? Four. So it is tetra. Okay, tetra amine. Okay. Now this is what type of complex? This is a positive, that is a cationic complex because the charge is plus 2. Right. The charge cationic means what? The overall charge on the complex, if it is in positive charge is there, then it is cationic. Okay. On this complex, the charge present is plus 2. So this is a cationic. So the name of the metal is what? It is copper. So it won't change. It will be copper itself. Okay, now we'll see the oxidation state. So copper is X plus this is 0 equals to plus 2. So X is equals to plus 2 only. Okay, so it will be plus 2. So this is plus 2. Okay, it is plus 2. Ammonia is neutral molecule. Yes, it is 0. Okay, ammonia is neutral molecule, it will be 0. Is it clear? So like this, whenever you have a cation complex, it will be same. So what will be the charge? It will be 2. So you will write it as, so copper SCN 4 2 minus. Now you try this. Now you try this. Yes, I want answer for this second example. I want answer for this. Try. This is what SCN. I have given you the list, okay, of the ligands, negatively charged ligand and neutral ligands. So this comes under negative ligands. Yes, what is the name? It is, what is the name of the complex? So if you don't try, then you will not understand. Okay, if it is wrong also, no problem. You have to try. You need to try. If you try, okay, it will, if your answer is correct, it will give you confidence. Okay. If you don't try, then you will not create interest only. So you will just try how to write the name of this complex. Very interesting topic this is. Okay, coordination compound is very interesting topic. Okay, Yamuna has tried tetrathiocyanato. Okay, so your half answer is correct. Okay, I can see your half answer is correct. So tetra, tetrathiocyanato. Okay, this much is correct. What type of complex is students? It is, what is the charge on the complex? It is negative. Now, whenever you have, then it is anionic complex, right? You have, whenever you have a negative charge on the complex, it is called is there, right? So your, it will end with ATE. Okay, it will end with ATE. Copper, no, copper. I forgot. Hmm. Yes, what is the name? So I just tried it, went down. Hmm. So second example, SCN, okay, 4 minus 2. So the name is what? Tetracyocyanato. Okay, this much is correct. So it will end with what? Copper. Okay, so copper, right? So it will be copperate. Okay, it will be E will be, so it is cooperate. So your, it will end with ATE. It will end with what? Yes, it will be cuprate. Yes. Okay. That only I'm getting confused with the spelling. Okay, cuprate. Cupprate. Okay, cuprate. Fine. So correct. Now it is correct. So cuprate. Now what is the charge? Copper X. Okay, minus 4 equals to minus 2. So x is equals to minus 2 plus 4, x is equals to plus 2. So the charge on the complex is 2. So you have to write it in Roman number. Okay, very good. Okay, Yamuna has answered it. Very good. So I want others also to try. So we are going to solve many such complexes. So everyone should answer. Okay, so there are 7 peoples. Okay, so everyone should answer. So we are going to solve some um, 13 plus 11. 13 plus 11, 4, 24. 24 to 25 names. Okay, so everybody should at least answer 2, 2. Okay, so let us start. Okay, so after naming the complex, what is the next step? That is, you have to write the oxidation state of the central metal ion and how it is represented. It is represented in the Roman numbers, right? So these are the rules. Now let us start with the naming the complex. So I'll take a blank slide. Okay, I'll take a blank slide. Okay. So let us see first anionic complex. Okay, let us see first anionic complexes. Now you know that what are the rules for anionic complexes. Okay, so whenever the central metal is there, it will end with ATE. Okay, fine. So let us see. Let us start. So potassium, please note this down. Ag. Okay, Cn. So whatever things I have given you, the names of the ligands and all, so keep everything beside you and start naming the compounds. Okay, tell me. Yes, tell the name. Who wants to answer? Everyone should be answering now. Yes, let me see who will answer first. Yes, nobody. Yes, nobody wants to answer. Now, yes, how I'll tell you why it is anionic complex, right? There is no charge. You can see for balancing the charge, they have added here the cation, right? So if you remove this cation, it will become -1. The charge will be -1. Here it will be again -1. So instead of writing the charge on the complex, if there is a cation present outside the sphere, then it is termed as anionic complex. Okay, it is an anionic complex. Yes, start answering now. What is the first complex? First, you have to, okay, let me give you first one. So first you have to name the outside the sphere complex, that is potassium. Okay, potassium. Then how many, what is the ligand? It is cyanido. Okay, it is cyanido. How many, these are there? Two are there. So it is dicyanido. Then dicyanido. What is Ag? It is arginate. Okay, argintate, Ag. Okay, so, and what is the charge? It is 1. It is 1. Suppose x minus 2 equals to -1. Okay, x minus 2 equals to -1. So x equals to -1 plus 2. So it will be 1. Is it clear? Okay. Next one, second one, try answering now second one. Try answering second one. Similar like first one. Again, it is a cyanido. Okay. So outside the sphere, you have sodium. So I'll write it as sodium. Then dicyanido, dicyanido. And what is Au? It is aurate. Okay. It is aurate because it is a negative charge. And what is the charge on the complex? So x again -2 equals to -1. X is equals to +1. Right. So it is 1 again. So this is the sodium dicyanido aurate 1. Yes, Sri Veroni has answered it correct. Very good. So others also please try. I want now answers for everyone. Okay, so I have solved two examples. Now you need to tell me the answer. Third one, K3FeCN6. Okay. Yes, Yamuna has also answered for previous one. Sodium dicyanido. Okay, dicyanido aurate. Don't do any mistakes in spellings also. Okay, when you're writing the nomenclature, if any spelling mistake is there, then there will be, they'll put directly wrong. Okay, so spelling should be correct. Yes. Third one, try third one. Try third one, students. Let me give you two more complexes. Yes. Third one, try students. Third one. Yes, third one. Okay. Hexacyanidopherrate. Okay. Sri Varuni has answered it as hexacyanidopherrate. Okay. Potassium hexacyanidopherrate 3. B. Gowda has answered. Potassium hexacyanidopherrate 3. Yes, very good. So, who is this? Uh, B. Gowda has answered it correct. Yes, potassium hexacyanidopherrate 3. Yes, Shri Varuni has also answered. Baby has also answered. Okay, so the name is what? Potassium, potassium, hexa, okay, hexacynido, then ferret and 3. The charge is 3. Okay, fourth one, students, very good, very good. So like this, you please try. Fourth one, this is C2O4. I have given you in the list the name. Yes, C2O4. No, it is not there. So this is, what is the name? C2O4 oxalato. Okay, C2O4 2 minus, right? So this is oxalato. Oxalate, right? So that is oxalato. C2O4 2 minus. So this is oxalato. So now try. So again, what will come? What will be the name? Potassium. Okay, I've got some answers. Potassium trioxalato chromate 3. Potassium trioxalato chromate 3. Very good. Potassium trioxalato. Yes, very good. Yamuna and Shivaruni has answered it right. Very good. So potassium. Okay. So three oxalates are there. So trioxalato. Okay. And chromate 3. Very good. Okay. So, so the charge, so how to find your K, so X, okay, oxalato charge is -2, -2 into 3, -2 into 3, okay, equals to -3. Let me see. So -6 is equals to 6. This is equals to 3. So the charge is +3. Got it? So oxalato charge is -2. So there are three oxalato. So 2 into 3. So it is -3. So like this. So charge is found out. Okay, next one. Try next one, fifth one. Try fifth one. Yes. What is the fifth one? Fifth one is what? Potassium. Potassium. Okay, fifth one is potassium. Then how many? This is Cl, right? So tetrachlorido, tetrachlorido. Then palladate. Okay, palladium it is. Pd is palladium. So we write it as palladate. Okay, palladate. So what is the charge? So palladate X minus 4 equals to minus 2. Potassiums are 2, so it is minus 2. So if you remove potassium from here, it will be minus 2 charging. So if you remove potassium from here, it will be minus 3 charge, right? So like this. So considering that, what I'll write, it is minus 2 here. Now, so X is equals to minus 2 plus 4, it is X is equals to plus 2. So palladium, it is pallate 2. Okay, very good. So potassium trichlorido, potassium trichlorido, no, tetra, 4 are there. Okay, so it is tri, so it is potassium tetrachlorido. 4 are there, no? 4 means tetra. So tetrachlorido, palladate 2. Okay, sixth one. No, 2 are there here. This one, fifth one I'm talking about, not sixth one. CL3. This is okay. Fifth one, fifth one. Okay, see this one. Four are there. Now you go for sixth one. Now go for sixth one. Sixth one, you tell me what is the answer for sixth one? Sixth one. So it can be written as potassium, platinum. So here two types of ligands are there now. One is a amine group. And so here the charge is what? It is minus 1. Okay, so platinum minus 3. Okay, this is 0 plus 0 equals to minus 1. So x is equals to minus 1 plus 3. X is equals to 2. So the charge on the platinum is plus 2. Okay, write down the name now. So first will be your potassium. First will be your potassium. Then between chlorido and amine, which will come first? Yes, anybody? Between chlorido and amino, which will come first now, which is alphabetical order, amine will come first. Yes, very good. So how many amines are there? One amine. So let us write potassium, amino, amino. Okay, how many chloro groups are there? Tri. Three are there. So it is trichloro. Okay, trichloro and platinate. Okay, it is platinate. What is the charge? It is 2. It is 2. Okay, potassium, mono, no. Mono, you should not write. Ah, okay, fine. Mono amino you can write. Mono amino tetrachlorido platinate 2. Okay, so that this should be there. Charge should be there. Okay, potassium amino trichlorido platinate. You have to mention the this. What is that? Oxidation number. Oxidation number is important. If you don't write oxidation number in the exam, no marks. So complete information should be there of the complex. Okay. Now let us go for the next one. So let me clear this. Okay. Seventh one. Let us write it here. Seventh one KMnO4 and eighth one K2NiCl4. Yes. Seventh one. What is the name of seventh one? Potassium. Mn is there and O4 is there. O4 is the your ligand. So it is potassium, potassium, tetra, tetraoxido, okay, tetraoxido manganate. Manganate. What is the charge? Let us see. Mn, okay, x plus 4 into minus 2 equals to minus 1. Okay, so the charge, because potassium 1 is there, so if you remove potassium, it is minus 1 here. So it will be minus 1. So what it will be? X minus 8 equals to minus 1. X is equals to minus 1 plus 8. So x is equals to plus 7. So it is plus 7. See, everybody is getting the same. So potassium tetraoxido manganate, manganate 7. Okay. Okay. Eighth one, name of the compound. Eighth one, potassium tetraoxido. Okay, manganate 7. Yes, Sri Varuni has answered. Baby has answered. Yamuna has answered. Very good. Okay, next one. Next one. Next one. Eighth one. Potassium. 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 Yes. How many chlorido groups are there? How many chlorido? 4. So it is named as tetra. Tetrachlorido. Okay. And nickelate. Nickelate. What is the charge on nickelate? So potassium, let us see. So nickel x minus 4 equals to minus 2. So x is equals to plus 2. So the charge is plus 2. So let us write it 2. Potassium tetrachlorido nickelate 2. Yes, very good. PP has answered it. Very good. Okay, so please see you don't do any mistake in spellings. Okay, nickelate spelling is wrong, so don't do mistake in spellings. Okay, fine. So let us go. So we have seen some 8, right? So let us clear this. So we will see remaining ninth one. K. So now we had seen one type of ligand, right? Then we have seen two type of ligand. Now we will see like if you have more than two ligands, what will happen? So chromium, CO3 twice and NH3 twice. So now you have two different ligands. Okay. So now the difficulty in naming the compound will be increased. Okay. Slowly we will see different ligands. Yes. Yes. Now others, what are they? Yes. Charan, Harshita, Sharan. Yeah. This also please try. Let us together solve this. 11th one. KCO C2, this is cobalt, okay, not carbonyl, CO. Then CKO, C2O4 twice, NH3 twice. Okay, then 12th one, HG, CO cobalt is CN4. Then 13th one, K3FE, C2O4 thrice. So this completes our what? Anionic ligands. Okay, so first we will name this, then we'll go for cationic anions. FeC2O4 thrice. Yes, name this now. Start naming. 5 are there. 5 people, 5. Okay, who will tell first one? Who want to tell first one? Sharon, will you tell? Try. The CO3, what is C? Okay, I'll help you out. This is amine. NH3 is amine. right? Amino. And CO3 minus 2 is what? It is a your carbonato. Okay, carbonato. Carbonyl group, right? Potassium diamine dichromate chromate 1. No, no. It is carbonato. Okay, your carbonates. So it is carbonato. Okay, it is carbonato. So potassium is correct, first one. So let us write potassium. Okay, first one is potassium. Then you have amine and you have carbonato. So amine will start with A and this will start with Ca. So how many amines are there? So first will be alphabetical order, amine will come. So how many amines are there? Two. So it is diamine. Okay, it is diamine. Then how many carbonato are there? Two. So it is dicarbonato. Carbonate. Carbonate. Okay, not carbonato, carbonate. Okay, carbonate, dicarbonate. Then Cr is what? Your chromate. As it is a negative complex, so we are going to write chromate. So let us see the charge. So X, okay, X, then X CO3 minus 2. So there are 2. So minus 2 into 2 plus 0 equals to minus 1. Okay, if we remove this potassium, it will be minus 1. So just see what will be the charge now. So it is X minus 4 equals to minus 1. X is equals to minus 1 plus 4 equal to plus 3. So the charge of chromate is plus 3. So your name, what is the name of the compound? The name of the compound is potassium diamine dicarbonate chromate 3. Yes, potassium diamine dicarbonate chromate 3. Yes, very good. Okay, very good. So let us see next one. I hope you are understanding. Okay, so let us see next one. Okay, next one. So you have NO. NO is your nitrosyl, right? Nitrosyl. NO, just see what I have given for NO. NO. NO is nitrate, nitro, nitrosyl. Yes, NO is nitrosyl. Okay, NO is nitrosyl. NO2 is nitrito. Okay, when you have NO2 minus, it is nitrito. So don't get confused. So nitrosyl is different, nitrito is different. Okay, so right now, and CN is cyanido. So if it is Na2, the charge will be minus 2. Okay, so X neutral, I think 0 equals to, it is plus 3. X is equals to plus 3. Yes. Okay, sodium pentacyanide. Okay, pentacyanide nitrosyl ferrate. And what is the charge? It is 3. Yes, very good. Sri Varuni has answered it correct. So it is sodium, then pentacyanide. Okay, then nitrosyl, because you have only one nitrosyl, then ferrate 3. Okay, very good. Next one. Next one, students. So 3 more are there. Yes. Next one. So again, C2O4 is oxalato. C2O4 is oxalato. And NH3 is amine. So O and amine, A, and this is cobalt. CO is cobalt. Okay. Right. This first charge on the complex. Okay. So cobalt X, then oxalato is minus 2, C2O4 into 2, and diamine is 0 equals to minus 1. So X is equals to minus 4 equals to minus 1. So X is equals to plus 3. So the charge will be plus 3. On cobalt, the charge is +3. Okay. Write down, start naming the compound. First will be your potassium. So let us write potassium. Next is what? Between oxalato and your amine. Amine will come first. So diamine, right? Potassium diamine, then dioxalato, then cobaltate 3. Cobaltate, AT, right? Because it is a anion. So it is cobaltate 3. Yes, very good. Shivaruni has answered it. Dioxalato, cobaltate 3. Very good. Next one, last two. Your Hg is mercury. Hg means mercury. This is thiocyanate. Okay, now you can do. So if I find a charge, Hg is also +1. So x is equals to x is equals to x minus 4 equals to -1. So x is equals to +3. Okay. Write down the remove Hg, it will be -1. Okay. Tell me, what is the name? Mercury. Mercury, okay. Mercury thiocyanate. Yes. Mercury tetrathiocyanate cobaltate 3. Very good. Yes, Yamuna, baby. And yes. Okay. So mercury tetracyanato. Okay. Tetracyanato cobaltate 3. Very good. Okay. Last one. We are left with last one. Last one. I hope you are writing down this. Yes, mercury tetracyanide, not cyanido, cyanato. Okay, cyanato, cobalt 3. Yes. Last one. Again, you have oxalate only. Okay, C2O4. So X FeX plus charge is -2 into 3. 3 oxalate are there equals to charge. If we remove K3, it will be -3 here. So X minus 6 is equals to -3. X is equals to +3. So if you solve, it will become +3. So what is the name? Potassium uh, yes, potassium trioxalatoferrate 3. Very good. So potassium trioxalatoferrate 3. Very good. So this completes our names for anionic complex. Okay. So this time. Okay. So the remaining, so we have to name now the cationic complexes. Okay. We have to name the cationic complexes. Then we have to name the complexes which are containing both cationic as well as anionic complexes. Okay. So in the next class also we are going to see the nomenclature only. So nomenclature very important for your board exam point of view as well as your competitive exam point of view. So these things are very important. So I hope you are making down the points for nomenclature and all the things, okay? Because this is a very scoring topic, okay, and very interesting topic. So if you practice these examples, okay, so and if you know the certain rules, you can score very well in naming these compounds. Fine. Okay. Um, so we have left with the other things for nomenclature. So that we'll see tomorrow. Okay. Very short time. Yeah, 10 minutes are there. So any doubts up to here? Any doubts up to here? Is it understood? Others, Charan, Harshita, Sharan. Yes. B. Gowda left. Okay. Okay, fine. Very good. Others, no doubts, right? Fine. So the remaining things we'll be discussing in tomorrow's class. Okay. So by this, I'll end the session here. Okay. We'll meet in tomorrow's class. Thank you. Have a good day.